partial fractions. Partial fractions is the thing which we are starting today. Okay, so there are four categories of partial fractions. The first category is distinguished linear factors. The first category is distinguished linear factors. I'll just write it for you. PF type 1, distinguished linear factors. Okay, I'll explain you the meaning of this via an example. Okay, so exercise 15B of OPM, question number 2. Okay, now there is one rule of applying partial fractions. When to apply? When to apply partial fractions? When the degree of numerator is less than degree of denominator. If the degree of numerator is less than degree of denominator, we apply partial fractions. Okay, just a revision. If the degree of numerator is greater than degree of denominator, we divide numerator with denominator. When the degree of numerator is equal to degree of denominator, we make numerator same as denominator. Okay, and when the degree is less, we can apply partial fraction or maybe some other thing. Okay, so when the degree is less, one of the ways of solving is using partial fraction. Fine. Okay, so we are going to the first category of problems, that is partial fraction type 1, uh, distinguished linear factors. So let's go to the second problem. Integration of 2x minus 1 upon x minus 1, x plus 2, x minus 3 dx. Okay, now what is the degree of the numerator over here? Can someone tell me what is the degree of the numerator? You can put it over chat. Degree of the numerator. Degree of the numerator is 1, correct. The degree of the numerator is 1. And what is the degree of the denominator? Degree is the maximum power of x. What is the degree of the denominator? Correct. So I got some answers. So degree of the denominator is 3 because we are multiplying all these three terms. So somewhere we'll get x cubed, right? So degree of the numerator is less than degree of the denominator. So we can use partial fractions. We can use partial fractions. Okay. So let this be equation number 1. The numbering of the equations is very important over here. Let this be equation number 1. Okay. Now this is category 1 partial fraction because we are having linear factors. Look at the individual brackets. These are linear factors. Why linear? Because within each and every factor, the degree of x is 1. Okay. The degree of x is 1. Right. So these are linear factors. Okay. And they are different from each other. They are not alike. They are different. Hence the name distinguished linear factors. Distinguished linear factors. Okay. So this is the first category, partial fraction. Okay. So for time being, we'll come outside integration. 2x minus 1, x plus 2, x minus 3, a upon x minus 1 plus b upon x plus 2 plus c upon x minus 3. So in the first category partial fractions, above each linear factor, take one variable over here. Okay, it's not a variable, but then it's a constant whose value which we don't know. So you can take ABC. You can also take PQR. Above each factor, take this. Let this be equation number 2. Let this be equation number 2. Now we are going to take the LCM of equation number 2. So 2x minus 1, x minus 1, x minus 2, x plus 2 into x minus 3 So let's take the LCM. So, so what is the LCM of all the three terms? So it will be written as x minus 1, x plus 2, x minus 3, right? Okay, so this is the LCM. Now besides A, which terms should be besides A? See, besides A, we'll have x plus 2 and x minus 3, right? X plus 2, x minus 3. If you're getting confused, what you should do is, you should divide this blue colored term with this red colored term. So x minus 1 will get cancelled. You'll be left with x plus 2, x minus 3. Fine. Plus B, blue colored term, that is the LCM term, divided by x plus 2. So x plus 2 will get cancelled. You'll be left with x minus 1, x minus 3. X minus 1, x minus 3. So this is pure LCM which I'm doing. Plus C into, plus C into the blue colored term divided by the red colored term. So x minus 3 will get cancelled. We'll be left with x minus 1 and x plus 2. Okay, right? So the next step would be to take LCM. I'll just write this once again. So 2x minus 1 upon x minus 1, x plus 2, x minus 3, LCM part x plus 1, x plus 2, x minus 3, a into blue colored term upon red colored term. So x minus 1 gets cancelled. Okay, so we are left with x plus 2, x minus 3 plus b into the blue colored term upon the red colored term. X plus 2 will get cancelled. So we are left with x minus 1 and x minus 3 plus c into the blue colored term upon the red colored term. So we are left with x minus 1, x plus 2. Now after we take the LCM, the three terms in the denominator from both the sides will get cancelled. Okay, the three terms from the denominator from both the sides will get cancelled and we'll be left with equation number 3. What is equation number 3? It is 2x minus 1 is equal to this entire thing. A into x plus 2, x minus 3 plus b into x minus 1, x minus 3 plus c into x minus 1, x plus 2. Okay, so this is equation number 3. Now look at each and every linear factor. Look at each and every linear factor. Now the first factor is x minus 1. Equate x minus 1 to 0. Equate x minus 1 to 0. What is the value of x that you will get? If you equate x minus 1 to 0, compulsory equate it to 0. It's a procedure of partial fractions. So if we equate x minus 1 to 0, the value of x that you will get is 1. Okay, the value of x that you will get is 1. Put that 1 in equation number 3. So next slide. Put x equal to 1 in equation number 3. Right? So 2 into 1 plus 1. See, wherever there is x, I'll just put the value of x as 1. Right? So a into 1 plus 2, 1 minus 3. Okay. Plus b into 1 minus 1, 1 minus 3. Plus c into 1 minus 1, 1 plus 2. Okay. So see, B and C will get eliminated. So this will be 3 is equal to A into 3 into minus 2. So A 3 is equal to minus 6A. So A is equal to 3 by minus 6, which is minus half. We got the value of A.
2x minus 1 na.
Sorry,
So it was 2x minus 1 na.
it's 2x minus 1. Let me check.
Yeah.
Yeah. Sorry, my bad. It's 2x minus 1. Correct. So this is 2x minus 1. And the left hand side will be 1. So this will be 1 and 1. So minus 1 by 6. We got the value of A. Okay. Now equate the second factor to 0. Equate x plus 2 equal to 0. If we equate x plus 2 equal to 0, what is the value of x that we'll get? What is the value of x that we'll get if we equate x plus 2 to 0? I think it's minus 2. Okay. Yeah, correct. So now we have to put this x as minus 2 in equation number 3. So let's put x as minus 2 in equation number 3. So 2 into minus 2 minus 1 a into in equation number 3 wherever you see x, see I have highlighted x, put minus 3 over there. Minus 3 plus 2 into minus 3 minus 2 plus 2, sorry, into minus 2 minus 3 plus b into minus 2 minus 1 minus 2 minus 3 and plus c into minus 2 minus 1 minus 2 plus 2. So if you see c term and a term gets eliminated, so we get minus 5 is equal to a into minus 3 into minus 5. This is minus 3 minus 5. Okay. So minus 5 will get cancelled on both the sides. Left hand side we are having a, right hand side minus 3a. Sorry, b. I'm really sorry for this. This is b. Okay. B into minus 3 into minus 5. Okay. So b will be 1 upon minus 3, that is minus 1 by 3. 1 upon minus 3, that is minus 1 by 3. Okay. Plus c. Now this time equate the third factor to 0. Equate this to 0. What is the value of x that you will get? If you equate this to 0, what is the value of x that you will get? If you equate this to 0, the value of x that you get is 3. Okay. The x value is 3 when you equate it to 0. Compulsory you have to equate it to 0. Okay. So put x equal to 3 in equation number 3. So 2 into 3 minus 1 equal to a into 3 plus 2 into 3 minus 3 plus b into 3 minus 1 3 minus 3 plus c into 3 minus 1 3 plus 2. So if you look at this, a and b terms will get eliminated because there is 3 minus 3 over here and here. right? We'll get the value of c. So 6 minus 1, that is 5. C into 2 into 5. So 5 and 5 gets cancelled on both the sides. So 1 is equal to 2c, c is equal to half. Now once you get the value of ABC, which we already have calculated, put the values of ABC in equation number 2. Put the value of ABC in equation number 2. Next step, put ABC values into, so 2x minus 1 upon, write it entirely, x minus 1, x plus 2, x minus 3 is equal to a. A का value is minus 1 by 6, minus 1 by 6, x minus 1 plus b. B value is minus 1 by 3, x plus 2 plus c. C value is 1 by 2, 1 by 2, x minus 3. So these are the values of a, b and c, right? Now take a look at equation number 1. Okay, so in short, we have calculated this value. We have not integrated, we have applied the method of partial fraction, but then we have calculated this particular value of 2x minus 1, x minus 1, x plus 2, x minus 3. Okay, so from 1 we have integration of, instead of this, we'll write down the right hand side, minus 1 by 6, x minus 1 plus minus 1 by 3, x plus 2 plus 1 by 2, x minus 3 dx. Okay, now this is individual integration. After this we are having individual integration, right? So in individual integration, the constants will go outside. So this will be minus 1 by 6 integration of 1 upon x minus 1 dx plus minus 1 by 3 integration of 1 upon x plus 2 dx. So let minus 1 upon 3, 1 upon x plus 2 dx plus half outside, 1 upon x minus 3 dx. Okay, now this is minus 1 upon x. See, each and every integral you can solve using two categories, f dash x upon f of x or log mod f of x formula. Okay, so this is log mod x minus 1 upon d by dx of x minus 1, that is 1, chain rule. Log mod x plus 2 upon d by dx of x plus 2, which is eventually 1. Okay, plus half log mod x minus 3 upon d by dx of x minus 3. Okay, which is 1. So this is your final answer. This is the basic problem of, partial fractions type 1. Partial fractions type 1. Okay, so look at OP Malhotra question number 1. Integration x minus 1 upon x plus 1, x minus 2 dx. Okay, now if you take a look at this particular problem, fine. So the degree of the numerator is 1, degree of the denominator is 2. Okay, and these are linear factors. These are two different linear factors. So basically we can just solve this, right, using partial fraction type 1. So x minus 1 upon x plus 1, x minus 2 is equal to a upon x plus 1 plus b upon x minus 2. This is how we are supposed to proceed. Now, what I would recommend is to, you solve this at your end and please send me the solution. So basically, some more cases in which we can use partial fraction type 1 is, let's take 15b question number 3, in which it is given as integration of x plus 7 upon x square plus 2x minus 8 dx. Okay. Now, if you carefully look at this, okay, we can factorize this. Okay, we can factorize this. So the degree of numerator is 1, degree of denominator is 2. We can apply partial fraction because we can certainly factorize the denominator. So x square plus 2x minus 8 can be written as x square plus 4x minus 2x minus 8, x plus 4 minus 2 x plus 4. So x minus 2 x plus 4. Okay, and then this will be your equation number 1, and then you can solve using partial fractions category 1. Okay, distinguished linear factors. So whenever you are able to factorize the denominator, please factorize the denominator and solve. So in OP Malhotra textbook, question number exercise 15b, question number 1, 2, 3, 5 and 6. Okay, these are specifically partial fractions type 1 problems. You can practice it on your own, right? Now I will select a case in which we cannot really factorize this denominator. So I'm giving you an extra problem because we need to think in that way also. So for example, the question is x plus 2, x square plus 3x minus 8. So tell me, can we factorize the denominator, yes or no?
No, sir.
So half into coefficient.
No. See, the first and foremost thing is we cannot factorize the denominator. Okay, so applying partial fractions will be difficult. We cannot even apply half into coefficient of x, half into 3 the whole square. This method also is not applicable because we don't have a constant in the numerator. We have x plus 7, right? So what basically we can do is, what is the derivative of the denominator?
2x
What
plus
is the derivative of the, okay, correct, 2x plus 3. So we'll make the numerator as 2x plus 3. Okay. So step number 1, multiply and divide. So 2x plus 3, I'll just write it down over here because it's a derivative of the denominator. So first step is half. Okay, multiply and divide with 2 because you are making this as 2x plus 3. So this is half 2x plus 7 upon x square plus 3x minus 8. Okay, now since we require 2x plus 3 over here, okay, what we can do is we can split that 7 as 3 plus 4. So this is half 2x plus 3 plus 4 x square plus 3x minus 8 dx. Next step, we will split integration of 2x square plus 3, 2x plus 3 upon x square plus 3x minus 8 dx plus 4 plus 4 x square minus 3x minus 8. Okay, now we'll take this as I1 and we'll take this as I2, and we have discussed such kind of problems. I1 can be solved using f dash x upon f of x. I2,
sir,
I2 we
half
can
into
take this 4
coefficient.
outside. We can take this 4 outside and we can write integration of 1 upon x square minus 3x minus 8, and then you can use, for I2 you can use half into coefficient of x the whole square integration. Okay, that method, combining squares. So basically while copying I just made a mistake over here. So Just a second. When I multiply this 2 inside, it will be 2x plus 14. Okay. 2x plus 14, right? Yeah. Now we have to make this 14 as 2x plus 3. So we can split this 14 as 3 and 11. So this will be 3 and 11. Sorry for this, right? So we can take that 11 outside. So we will solve some more problems based on partial fractions type 1, but then certain adjustments are supposed to be made while solving. So exercise 15b, question number 4, integration of x upon x square minus 3x plus 2 dx. Okay, right? Now, in this particular problem, if we are able to factorize the denominator, let's do it. Can we factorize the denominator over here?
Yeah.
So tell me what is the denominator after factorization. You can solve it at your end and tell me. Are you getting x minus
X
1, x
minus
minus
2
2?
into, yeah.
Okay. So let this be equation number 1. Since we are able to factorize and solve. If we are not able to factorize this, then calculate the derivative of it and make numerator the derivative. Okay. So in that case, when we are not able to factorize, partial fraction type 1 won't work. Okay. Next example. Question number 10 from exercise 15b. From exercise 15b, question number 10. Integration of sine theta cos theta upon cos square theta minus cos theta minus 2 d theta. Okay. Now there is trigonometry involved over here. We'll put cos theta is equal to t.
So this is sine 2 sine theta by 2, na?
Don't apply half angle formula. D by d theta of cos theta is equal to d by d theta of t. Okay. What is the derivative of cos theta? Derivative of cos theta is minus sine theta. dt by d theta. Okay. So in the main question, what will be sine theta d theta replaced with?
So dt and t will be cos theta, and you take minus outside.
Minus sign outside.
Correct. So it will be minus dt. So here integration of sine theta d theta is minus dt. Okay. Now cos theta is t everywhere. So t upon t square minus t minus 2. T upon t square minus t minus 2. Okay. Just copy this. In the first step, I have applied method of substitution. In the first step, I have applied method of substitution. Okay. Now I would take this minus sign outside. So I outside t upon t square minus t minus 2 minus t minus 2 dt. T upon minus t minus 2 dt. Fine. Okay. So can we factorize the
Yes, so
denominator?
we can.
Okay. So t square minus t minus 2 is t square minus 2t plus 2 minus plus t minus 2. Okay. t t minus 2 plus 1 t minus 2. Okay. So we can write I as minus sign outside, t t minus 2 t plus 1 dt. Now let this be equation number 1. Let this be equation number 1. The degree of the numerator is 1 and the degree of the denominator is 2. We can apply partial fractions. We can apply partial fractions if and only if the degree of the numerator is less than degree of the denominator. Then only we can apply partial fractions. Otherwise we cannot. Okay. So let's go to the partial fraction method. We'll consider only the inside part. The method of partial fraction says that this is distinguished linear factors. So this is A and this is B, right? Okay. Both are distinguished linear factors. So above t minus 2, I'll take A. Above t plus 1, I'll take B. So t upon t minus 2 t plus 1 is equal to A upon t minus 2 plus B upon t minus 1, equation number 2. Take LCM on the right hand side, t minus 2 t plus 1, A into t minus 1, B into t minus 2 upon t minus 2 t plus 1, t minus 1, t minus 2 t plus 1 on both the sides will get cancelled and you will get equation number 3. Okay.
So it's t plus 1, not minus 1 with A.
Oh, sorry. Yes, so you can just correct wherever I'm making any copying mistake. Okay. So there are two factors. What should I equate t minus 1 to?
2.
What should I equate t minus 2
T
to?
is equal to 2.
We'll equate t minus 2 to 0. So we'll get the value of t as 2. We'll get the value of t as 2. Okay. So put t is equal to 2 in equation number 3. So 2 is equal to a into 2 plus 1 plus b into 2 minus 2. So what is the value of a? Is it 2 by 3?
Yes, sir. And B is 1 by 3.
Okay. Now equate t plus 1 to 0. Equate to t plus 1 to 0. When we equate t plus 1 to 0, the value of t is minus 1. The value of t is minus 1, right? So for the second iteration, put t value as minus 1 in equation number 3. In equation number 3. So let's do that. T is equal to minus 1, a into minus 1 plus 1, b into minus 1 minus 2. Okay, so a is eliminated. So minus 1 is equal to minus 3b, b is 1 by 3. Okay, so a is 2 by 3, b is 1 by 3. Guys, where to put the value of a and b? In which equation at the beginning?
2.
After this, numbering of equation substituting is very important. So we'll put the value of a and b in equation number 3. Put a and b in equation number 3, right? Okay. So t upon t minus 1 t plus t minus 2 t plus 1 a is 2 by 3, b is 1 by 3. Okay, in equation 2, sorry, not in 3. From equation number 1. Now what is 1? 1 is this. So we got the value of this entire blue colored part. We got the value of this. Okay, so that we will replace. I is equal to minus sign outside. There is already a minus sign outside. See, and replace t minus 2 t plus 1 with 2 by 3 t minus 2 plus 1 by 3 t plus 1 dt. We are integrating with respect to t because I have taken method of substitution. Okay. After this, I'll go ahead with individual integration, but then take this minus sign to both the terms and take the constants outside integration sign. So minus 2 by 3 1 upon t minus 2 dt minus 1 upon 3 integration 1 upon t plus 1 dt. Right? I've given the minus sign to both the integrals. Okay, and taken the constants outside. Fine. So this is minus 2 by 3 log modulus t minus 2 upon d by dt of t minus 2. Chain rule. I've applied 1 upon x formula. You can also apply the property of f dash t upon f of t. Log mod t plus 1 upon d by dt of t plus 1 plus c. So this is minus 2 by 3. See, down both the derivatives are 1. These two terms will be 1. But then what is the value of t?
Cos theta.
T is nothing but cos theta. So put the value of t as cos theta. Cos theta minus 2 minus 1 by 3 log mod cos theta plus 1 plus c. So in a nutshell, to
So we made a
So
mistake at
down,
the
wait,
you,
wait,
beginning.
so down you'll have to take minus sine theta, na?
uh, where
d by
minus sign?
So
d
see,
d by
so
dt of t minus 2, d by dt of cos theta minus 2, which is sine theta minus sine theta.
No, 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 no. That do you don't get confused over there. See, down don't replace. Actually, see, we first have to derive, and then I've written two steps in one at one go. So basically, this is the first step. This is the first step. Okay, guys. Down it is 1. Down it is 1. Agreed?
Yes,
Yes or
sir.
no?
Yes, sir.
Okay. And then once you do this, in the final step, you write Ts
Cos theta.
cos theta. So does it make sense now?
Yes, sir.
Okay. So guys, we are starting with partial fraction type 2. Okay. This particular type is disguised linear factors. Disguised linear factors. Okay. So when I take up one problem, that time it will be more clear. So go to exercise 15b, question number 16. Exercise 15b, question number 16, integration of x square x raised to 4 plus x square minus 2 dx. Fine. Okay. Now see, first discussion is in exercise 15a, there are some problems of the category x square upon x raised to 4, where we divide throughout by x square, right? But then in this problem, we can't do that because this 2 is not a perfect square. Because this 2 is not a perfect square. So if you recollect the problems from exercise 15a, okay, such type of problems were only for perfect squares, right? So that won't work over here. Now, first of all, if you take a look at the denominator, we can factorize the denominator. So x raised to 4 plus x square minus 2 can be written as x raised to 4 plus 2x square minus x square minus 2. So x square plus 2 minus 1 x square plus 2 x square minus 1 x square plus 2. Okay, we can factorize the denominator. First of all, the category is disguised linear factors. Okay, have you copied this much? Fine.
One second.
So now what I'm going to do is, while writing the next step, I'm going to replace this denominator. I'm going to replace this denominator with the factorized terms, the two factors in the next step. Okay, so x square upon I is equal to x square upon x minus 1 x square plus 2 dx. Now see, everywhere there is x square over here. Okay, so this gives us the hint that we can apply second category partial fractions over here. So x square upon x square minus 1 x square plus 2. Let's take this x square as some other variable. Let's say m upon m minus 1 m plus 2. See, we are not using method of substitution. Huh? This is not method of substitution. Hence, I'm not using the variable t. In the method of partial fraction, within the method of partial fraction, we are considering x square as m. Okay, so this is equation number 1. We got equation number 2, right? So next step, m upon m minus 1 into m plus 2 is equal to a upon m minus 1 plus b upon m plus 2. Now I'll explain you why this particular type is called as disguised linear factors. This particular category is called as disguised linear factors is because we converted the problem into distinguished linear factors. When we started the problems, it was not linear factor at all. Okay, see, these are not linear factors. These are not linear factors. Okay, so we converted the problem into linear factors. Okay, we converted the problem into linear factors. M minus 1 m plus 2 is linear factor. Now since we converted the problem into linear factors, it is called as disguised linear factors. Fine. Now we can solve this like the previous method. Let this be equation number 3. Okay, okay, so next step, m into m minus 1 m plus 2 is equal to a into m plus 2 plus b into m minus 1 m minus 1 m plus 2. This terms will get cancelled on both the sides. This will be equation number 4. Okay, this will be equation number 4. Now look at the linear factors. Look at the linear factors. If we equate m minus 1 to 0, if we equate m minus 1 to 0, the value of m is 1. The value of m is 1, right? So let's put m is equal to 1 in equation number 4. This time we get one more equation. Okay, so that's why it's equation number 4. So put m is equal to 1 in equation number 4. So 1 is equal to a into m plus 1 plus 2 plus b into 1 minus 1. 1 is equal to 3a. A is equal to 1 by 3. A is equal to 1 by 3. Okay. Now look at the other factor, m plus 2. If we equate the value of m plus 2 to 0, what is the value of m that you will get? You can put it over the chat box. If you equate m plus 2 to 0, what is the value of m that you will get?
2 by 3. B M is minus 2 and B is 2 by 3.
Okay, let's put m as minus 2 in equation number 4. So minus 2 is equal to a into minus 2 plus 2 plus b into minus 2 minus 3. So minus 2 is equal to minus 3b, because this will get eliminated, a will get eliminated. So b is equal to 2 by 3. We got the value of b. We got the value of b. Don't proceed ahead because there might be certain errors which might occur. So stay along with me. Okay. Stay along with me. So put the values of a and b now in equation number 3 first. Put the value of a and b in equation number 3. So I'll write from 3 m into m minus 1 m plus 2 a. The value of a is 1 by 3. So put a as 1 by 3 over here. 1 by 3 upon m minus 1 plus b. The value of b is 2 by 3. The value of b is 2 by 3. You put it in equation number 3. So this is m plus 2. Okay. Now before we integrate, this m is not a variable of method of substitution. M we took for our convenience within partial fractions. So replace m by x square. This is a very crucial thing. In method of substitution, we don't do this. We directly integrate with respect to t. With respect to t. But then in second category partial fraction, first replace this m by x square. Okay. Right. Now we can go back to equation number 1. Now we can go back to equation 1. Okay, because we got the value of this. इसका value मिल गया है, right? So integration, that is from equation number 1. Integration. So I'll write from 1. I is equal to integration of this entire thing. 1 by 3 upon x square minus 1 plus 2 by 3 upon x square minus 2 dx. 1 by 3 integration of 1 upon x square minus 1 square dx plus 2 by 3 integration of x square minus 2 square dx. X square minus root 2 the whole square dx. I'm sorry for that.
So why can't you substitute m as x square like in the end after you get f dash x?
Because m is not the variable for method of substitution. Have I done method of substitution anywhere using m?
No, sir.
No. So that's why before integrating, replace m with x square. In method of substitution, we replace t towards the end because we actually apply method of substitution in the problem. But then in partial fraction type 2, we don't do method of substitution anymore. Okay, now this formula is 1 upon x square minus a square in both the cases. So 1 upon x square minus a square, the formula is 1 upon a log mod 1 upon 2a log mod x minus a upon x plus a. So this formula we are going to use. Okay, so the next step will be I equal to, for both the terms we are going to use the same formula, 1 by 3 into 1 upon 2a log mod x minus a upon x plus a, okay, plus 2 by 3 into 1 upon 2a. So 1 upon 2a. In the second case, a is root 2. 1 upon 2a log mod x minus root 2 x plus root 2. Now moreover, what you can do is you can just simplify this. 2 will get cancelled. Okay, so that is how it works, right? This was second category partial fraction. Fine. So see question number 18 and question number 20. Question number 18 and question number 20 from exercise 15b. These are second category partial fractions. Okay, so you can practice these problems at your end. Just a second. So basically, guys, I'm just discussing one problem. That is question number 14 from the same exercise. Now, I want you all to think and answer like what should be the approach of solving this particular category of problem. Is this PF type 1 or is this PF category 2, type 2? Please tell me.
That's type
Type
1.
2.
See, this cannot be type 2, okay? Because everywhere there is not x square. Everywhere there is not x square, okay? It is certainly type 1, but then when you solve type 1, the first step won't be partial fraction. The first step will be method of substitution. Put x square is equal to t. Okay. So right now, all of you are solving this problem. You are going to solve using method of substitution, and then you are going to apply partial fractions and send it to me. Please start. Those who are struggling to get a solution for this, let this be equation number 1. Or if you don't number this equation, that's also fine. Put x square equal to t, d by dx of x square, d by dx of t, 2x dt by dx.
So can you check my answer?
So don't speak, please. 2x dx will be dt. Okay. So 2x dx I have grouped from here. 2x dx is equal to dt. So I is equal to 2x dx is dt. Numerator, nothing is left. So I'm writing 1. 1 upon t plus 1, t plus 2. Okay. The degree of the numerator is 0 because there is no t term. Degree of the denominator is 2. T into t will be t square, so the degree is 2. The degree of the numerator is less than degree of the denominator. Degree of the numerator is less than degree of the denominator, so we can apply partial fractions type 1. Okay, because we are having two factors down. These two are different linear factors. So it is category 1 partial fractions, that is distinguished linear factors. Okay, so let this be equation number 1. So we'll come out of the integration sign and we'll apply the method of partial fraction. So 1 upon t plus 1 into t plus 2 is equal to a upon t plus 1 plus b upon t plus 2. Equation number 2, take LCM. A upon t plus 2, b upon t plus 1, t plus 1, t plus 2. Both the denominators will get cancelled and we'll get equation number 3. Okay. Now look at the first factor, that is t plus 1. Equate t plus 1 to 0. Equate t plus 1 to 0. We'll get the value of t as minus 1. So put t equal to minus 1 in equation number 3. So 1 is equal to a into minus 1 plus 2, b into minus 1 plus 1. So this will give me a, as if you solve this, b will be eliminated and the value of a will be 1. Okay. Now equate the second factor to 0. Equate t plus 2 to 0. You will get t as minus 2. Okay. Put t equal to minus 2 in equation number 3. 1 is equal to a into minus 2 plus 2, b into minus 2 plus 1. So b equal to, okay, a will get eliminated. So b into minus 1 is equal to 1. So b is equal to minus 1. Now we are going to put the value of a and b in equation number 2. Put the value of a and b in equation number 2. Put a, b in equation number 2. So not I. Let's go to equation number 2. Wait. Yeah, 1 upon t plus 1 is equal to a upon t plus 1 plus b upon t plus 2. Right? Now from equation number 1, integration, we got value of this 1 upon t plus 1 t plus 2. So basically have this particular value 1 upon t plus 1. This now. Replace this with whatever got with partial fractions. 1 upon t plus 1 plus minus 1 upon t plus dt. Now if you observe, I'm going to replace t towards the end after integration because we have used method of substitution. Otherwise, unlike the previous type, that is type 2, m is replaced prior to integration. Now this is individual integration. Integration of 1 upon t plus 1 dt minus 1 upon t plus 2 dt. Okay. So this is log mod t plus 1. You can use any formula over here like 1 upon t formula or f dash t upon f of t property. Both ways you'll get the same answer. Okay. Upon d by dt of t plus 1, if you apply the formula, upon d by dt of t plus 2 plus c. Now d by dt of t plus 1 is 1 and d by dt of t plus 2 is 1. So I'm just erasing this off because the values are 1. Log a minus log b. Log a minus log b is log a upon b plus c. Finally, we are going to replace the value of t. We are going to replace the value of t with x square. That's your complete solution. So we are starting with partial fraction type 3. Okay, the category is repeated linear factors. Repeated linear factors. Okay, so let us go to exercise 15b, question number 13. Exercise 15b, question number 13. Okay, so now see, I'll just copy the question for you. 3x minus 2 dx x plus 1 the whole square upon x plus 3. Okay, now we'll start with our discussion over here. Yeah, so basically the degree of the numerator is 1 because there is x over here, and if you try to figure out the degree of the denominator, it will be 3, because when we multiply x plus 1 x plus 1 x plus 3, right, we certainly will get x cube. So the degree of the denominator is 3. Fine. Now there are two linear factors in the denominator. We are having x plus 1 and x plus 3. But then out of this one factor, that is x plus 1, is getting repeated twice. It is getting repeated twice. Okay. So that's the way, that's why it is called as repeated linear factors. So this is the third category. But then while solving partial fractions, always remember that the degree of the numerator should be less than degree of the denominator, and then only figure out whether it is type 1, type 2, type 3. Okay. So let this be equation number 1. Let this be equation number 1. 3x minus 2 upon, I'll just write down, I'll just come outside integration for a while. Come out of integration for a while. Okay. So 3x minus 2 upon x plus 1 the whole square x plus 3 equal to, okay, first write down non-repeated factor. Okay, please first write down non-repeated factor. So x plus 3 is a linear factor which is not repeated. Okay, so we'll write it down first. Okay, then write down the repeated factors. So b upon x plus 1 plus c upon x plus 1 the whole square. So now first of all, guys, this is the procedure of partial fractions. Like, we cannot just
You
So it
we
won't
cannot
be
follow.
whole square upon c now.
Sorry.
Will it be whole square upon c, like x plus 1 the whole square?
No. Partial fraction type 3 says first write down the repeated non-repeated factor, then target the repeated factor. So we have to write it once as the power 1 over here, and second time we have to write the same thing with power 2 because it is the whole square. So basically we have to follow this particular procedure. Okay. Now had it been cube over here instead of square, if it is cube over here, so there will be d upon x plus 1 raised to anyone?
3.
Raised to 3. Correct. Once, twice, and thrice. So basically we are moving as per the method of partial fractions. So we have to strictly follow this. the third category. Okay. Now the second part, this becomes the second equation. We are going to play with LCM over here. X plus 1 the whole square, x plus 3. Okay. LCM of all three terms. Okay. LCM of x plus 3 into x plus 3, x plus 1, x plus 1 the whole square is x plus 3 into x plus 1 the whole square. Guys, the LCM of x plus 1 and x plus 1 the whole square is x plus 1 the whole square. See, if you understand this, the LCM of 2 and 4 is 4. This means that the LCM of x and x square is x square. So what will be the LCM of x plus 1 and x plus 1 the whole square? What will be the LCM?
Plus 1 the whole square.
Correct. X plus 1 the whole square. Okay, so if you're understanding this, you will definitely understand why I'm writing x plus 1 the whole square instead of x plus 1. Yeah. So A, red colored term denominator divided by blue colored term. So if you cancel out x plus 3, you'll get only x plus 1 the whole square. You'll get only x plus 1 the whole square. Plus B, the red colored term upon the blue colored term. Okay. So if you cancel out, you'll get x plus 3 into x plus 1. Right. See, if you divide this with this x plus 1, 1 x plus 1 will get cancelled, right? Okay. Plus C. Okay. Red colored term divided by blue colored term. So what will you get? You'll get x plus 3. You'll get x plus 3. Fine. So this is how you get the LCM. And once you cancel the denominators from both the sides, you will get equation number 3. You will get equation number 3. Fine. So from equation number 1, I've got 2 and 3 using the method of partial fractions, category 3. Okay. I'll be going very slow with this. Equate x plus 3 to 0. If you equate x plus 3 to 0, you'll get the value of x as minus 3. So put x equal to minus 3 in equation number 3. Number the equations very clearly. So 3 into minus 3 minus 2. So wherever there is x, put minus 3. 3 into minus 3 minus 2 is equal to a into minus 3 plus 1 the whole square plus b into minus 3 plus 3 minus 3 plus 1 plus c into minus 3 plus 3. Okay. So if you see, b and c terms will get eliminated. We will be left with only a term. So the left hand side will be minus 11 a into, this is minus 2 the whole square. So minus 2 the whole square is 4. So a is equal to minus 11 upon 4. A is equal to minus 11 upon 4. Right? We got the value of a. Now equate x minus 1 to 0. When we equate x minus 1 to 0, we get the value of x as minus 1. So put x equal to minus 1 in 3. Put x equal to minus 1 in equation number 3. Okay. Once you do that, okay, let's see what happens. So 3 into -1 -2, a into -1 plus 1 the whole square, plus b into -1 plus 3 -1 plus 1, plus c into -1 plus 3. Okay, so the left hand side will become -5. Here a is getting eliminated and b also is getting eliminated because -1 plus 1 is 0. We'll be left with only c into 2. So the value of c is -5/2. We got the value of a, we got the value of c. Okay, third iteration, look at this factor x plus 1. Now x plus 1, we cannot again equate it to 0 because it has already been done in the second iteration. It's already done over here. So again, we cannot put x plus 1 as 0. Let it be square, but then we cannot put x plus 1 as 0 to get the value of x. We'll get the same thing because it's already done. So take the value of x as anything, any number apart from -3 and 1. Take the value of x as anything apart from -3 and 1. So let's take the value of x as 0 for the third iteration in this category. Simplest value. So put, you can take any value, but then don't take -3 and -1 again. X is equal to 0 in equation number 3. In equation number 3. So 3 into 0 minus 2, a into 0 plus 1 the whole square, plus b into 0 plus 3 0 plus 1, plus c into 0 plus 3. C into 0 plus 3. Okay. So left hand side will be -2. Okay. A into 1 square. 1 square is 1, plus b into 3 into 1, that is 3, plus c into 0 plus 3, that is 3. Okay. Now we will utilize the values of a and c which we have got earlier. So we can put the value of a as -11/4 and c as -5/2. Okay. So a is -11/4 plus 3b and c as 5/2. Okay. So please copy this. Now we are going to simplify this further. -2 is equal to -11/4 plus 3b plus 15/2 plus 15/2. I'll just write this on the next page. Okay. -2 -11/4 plus 3b plus 15/2. Okay. So this will become -2 plus 11/4 minus 15/2 is equal to 3b. Let's take LCM on the left hand side. So I'll multiply -2 with 4. This is 1 with 4. This is 1, right? Plus 11 upon 4 minus 15/2 upon 2/2. I took the LCM. While doing the LCM, I am making every term 4. Okay. So 3b equal to minus 8 upon 4 plus 11 upon 4 minus 30 by 4. So 3b is equal to minus 8 plus 11, that
27
is
by 4.
3. 3 minus 30, that is minus 27 by 4.
B
So
is
b
minus
is
9 by
equal to,
4.
correct, into 1 by 3. So b is equal to minus 9 by 4. B is equal to minus 9 by 4. Okay. So now, if you have seen, we have got the values of A, B, and C. We got the values of A, B, and C. Now we have to put these values of A, B, and C. We have to put these values of A, B, and C in equation number 2. In equation number 2. Okay. So I'll write from equation number 2, 3x minus 2 upon x plus 1 the whole square x minus 2 is equal to, first, the non-repeated factor x plus 3, sorry, I'm just copying this wrong. Non-repeated factor first. Now repeated factor repeated once, repeated twice. Put the values of A, B, and C. So A is minus 11 by 4. B is minus 9 by 4. And C is pi by 2. Okay. From equation number 1, integration minus 11 by 4 upon x plus 3 plus 9 by 4 minus 9 upon 4 upon x plus 1 plus 5 by 2 upon x plus 1 the whole square dx. Now we can individually integrate this. We can take the constants outside and individually integrate this. Minus 11 by 4 upon 1 upon x plus 3 dx minus 9 by 4 upon 1 upon x plus 1 dx plus 5 by 2 upon 1 upon x plus 1 the whole square dx. So minus 11 by 4 log mod x plus 3 upon dy dx of x plus 3. dy dx of x plus 3 is 1. Minus 9 by 4 upon into log mod x plus 1 upon dy dx of x plus 1, which is 1, plus 5 by 2. Now here we cannot apply 1 upon x formula. We cannot apply 1 upon x formula because if we apply 1 upon x, x is x plus 1 the whole square. Square is not linear algebraic term. So we have to write this as x plus 1 raised to minus 2 dx. And eventually we are going to solve this using x raised to n formula. Okay. So minus 11 upon 4 x plus 3 log mod x plus 3, sorry. Okay. Minus 9 by 4 log mod x plus 1 plus 5 by 2 x plus 1 raised to minus 2 plus 1 upon minus 2 plus 1, and there will be d by dx of x plus 1, which is 1. So minus 11 upon 4 x plus 3 minus 9 upon 4 log mod x plus 1 plus 5 upon 2 x plus 1 raised to minus 1 upon minus 1. Okay, the last step, you can copy this thing exactly same. This will be minus because this plus into this minus is minus 5 by 2, and take this raised to minus term down in the denominator. So that is 1 upon x plus 1 plus c. This is the final answer. So guys, we are going to solve one more problem of repeated linear factor. Okay, so let us go to question number 12, sub question 1. You can solve along with me. Okay, so basically I is equal to integration of x square plus x plus 1 upon x square into x plus 1 dx, equation number 1. Let's not write this as equation number 1, wait. Okay, we'll first understand the degree of the numerator. Degree of the numerator is 2, degree of the denominator is 3. Okay, so we can apply partial fractions because the degree is less. So let this be equation number 1, x square plus x plus 1 upon x square into x plus 1. So there are two factors down, one is x and one is x plus 1. X is a linear factor, x plus 1 is also a linear factor, but then x is getting repeated twice, hence it is repeated linear factor. The category becomes repeated linear factor. Okay, so this is a upon the non-repeated one, b upon x plus c upon x square plus c upon x square. Okay, so that's how it is supposed to be. X,
So it's
return
b
it 1.
upon x into x plus 1 now.
No, I'm not speaking about the LCM. I'm writing about the partial fraction category. So x is repeated once, x is repeated twice. Okay, like the previous problems. Then on the right hand side, I am going to take the LCM, x square into x plus 1. Okay, so the LCM of these three terms is x plus 1 into x square. Fine. So A, the red colored part divided by the blue colored part. So this will give me x square. Okay, plus B, the red colored part divided by the blue colored part. So one x will get cancelled. So x plus 1 into x plus C, the red colored part divided by the blue colored part. Okay, red colored part divided by the blue colored part. So this will give me C into x plus 1. Okay, now we can just cancel the terms on both the sides. Okay, right? So we have to put the values of x now one by one. Consider the
Minus 1,
first factor.
0.
Correct. So let us consider the first factor, that is x plus 1 equated to 0. The value of x is minus 1. So put x as minus 1 in 3. Put x is equal to minus 1 in equation number 3. So minus 1 the whole square plus minus 1 plus 1. Wherever there is x, put x as -1. Put x as -1, okay, in equation number 3. Solve systematically. A into -1 the whole square.
So what will the third value of x be?
Wait, I'm solving. Plus b into -1 plus 1 c into -1 plus 1. So if you check, one second, b into -1 plus 1 into -1. Here also there is -1. It does not make any difference, but then we have to be absolutely very systematic over here. Okay. So now this b part and c part gets eliminated because -1 plus 1 is 0. So 1, this is getting cancelled. A into 1. So A is 1. A is 1. For the second iteration, put the value of x as 0, because if we equate x to 0, the value of x will be 0. Put x equal to 0 in equation number 3. So 0 square plus 0 plus 1. A into 0 square plus b into 0 plus 1 into 0. A into 0 square plus b into 0 plus 1 into 0 plus c into 0 plus 1 plus c into 0 plus 1. Okay. So left hand side will be 1. A and b will get eliminated over here. And this will be c into 1, which is 1. I'm getting the value of c as 1. Okay. Now for the third time, again, we cannot take x as 0 because it is already been taken. So take the value of x as anything apart from -1 and 0. -1 and 0, take anything apart from -1 and 0. So let's take the simplest value. Let's take x as 1, which is quite valid. Let's take x as 1. Put x equal to 1. Put x equal to 1 in equation number 2. Put x equal to 1 in equation number 2. So 1 square plus 1 plus 1. 1 square plus 1 plus 1. A into 1 square. A into 1 square plus b into 1 plus 1 into 1 plus c into 1 plus 1. In this entire equation number 3. In this entire equation number 3. Sorry, I had written 2 over here. It's 3. I'm putting the value of x as 1. So this is 3a plus 2b plus 2c. Okay. Now the values of and b, a and c are 1. The values of a and c are 1. So let's solve this. 3 is equal to 1 plus 2, that is 3, plus 2b. So 2b is equal to 0, b equal to 0. 2b equal to 0, b is equal to 0. Now once we get the value of b as 0, let's put all these values. Let's put all these values in equation number 2. In equation number 2. Put a, b, c in equation number 2. Okay. So x square plus x plus 1 upon x square x plus 1. Many of you don't write this particular step, but then I insist you write as per the proper method. A, what is A? A is 1. 1 upon x plus 1 plus 0 upon x because b is 0 plus c. C is 1. 1 upon x square. Okay. Now from 1, see we have the value of this now. So from 1, this is getting replaced with whatever we have got by the method of partial fractions. Integration of 1 upon x plus 1 plus 1 upon x square dx. Now why this happens is because 0 upon x will be 0 and integration of 0 will be 0. After this particular step, I am going to integrate this individually. I'm going to integrate this individually. Okay. So it will be integration of 1 upon x plus 1 dx plus 1 upon integration of 1 upon x square dx. 1 upon x square dx. Okay. So further, this first part will be log modulus x plus 1 upon d by dx of x plus 1, which will obviously give you 0, plus integration of x raised to minus 2. So log modulus of x plus 1 plus x raised to minus 2 plus 1 upon minus 2 plus 1 plus c. Okay. So this is log modulus of x plus 1 plus x raised to minus 1 plus 1 upon minus 1 plus c. So this is equal to log modulus x plus 1. This plus into this minus will be minus. X raised to minus 1 is written as 1 upon x plus c. Okay. So we will be continuing with the same category. One more problem from exercise 15b, that is question number 11. Integration of 3x minus 1 upon x minus 2 the whole square. The degree of the numerator is 1, the degree of the denominator is 2, because we are having x minus 2 the whole square.
So we'll do
After
it on
expansion, it will be x square. Okay. So degree is less. Once the degree is less, we can apply partial fraction. Let this be equation number 1. So 3x minus 1 upon x minus 2 the whole square is equal to a upon x minus 2 plus b upon x minus 2 the whole square, equation number 2. Now see, down we are having a linear factor within the bracket, but then this particular linear factor, that is x minus 2, it is getting repeated twice. Okay. So hence I have written x minus 2 once and x minus 2 twice. Okay. So 3x minus 1 upon x minus 2 the whole square is equal to, take LCM. LCM is x minus 2 the whole square into the blue colored term upon the red colored term. So you'll get x minus 2 over here plus b into the blue colored term, the red colored term upon the blue colored term. Okay. 1 second, sorry. Upon the blue colored term. So that term is x minus 2 the whole square. Okay. So we'll get 1 over here. Cancellations. Cancellations. Okay. And then we'll get equation number 3. Okay. Now in the first iteration, you will equate x minus 2 to 0. When you put x minus 2 equal to 0, the value of x is 2. The value of x is 2. So put x is equal to 2 in equation number 3. Okay. in equation number 3, right? So wherever there is x, put the value of x as 2. 3 into 2 minus 1, a into 2 minus 2 plus b into 1. Okay, a will get eliminated. So 5 is equal to b. B is equal to 5. Okay, we got the value of b as 5. Second iteration, we cannot again take the value of x minus 2 as 0. We cannot take it. X minus 2 as 0. So what we need to do over here?
X equal to 0.
We'll take x anything else, any other value apart from 2. So let's take the simplest value 0. We can take 0, we can take 1, we can take 10, we can take 20, we can take 100, but then take simple values always. So put x equal to 0 in equation number 3. Three into 0 minus 1, a into 0 minus 2, b into 1. So minus 1 is equal to minus 2a plus b. Put the value of b as 5. So minus 5 minus 1 is equal to minus 2a. Minus 6 is equal to minus 2a. A equal to 3. A equal to 3. Fine. Yes or no?
Yes.
Now once we get the value of a and b, once we get the value of a and b, okay, where we are going to substitute the value of a and b? We are going to substitute the value of a and b in equation number 2. In equation number 2. Okay. Put the value of a and b in equation number 2. Right? I hope everybody is doing that. Put a and b in equation number 2. So equation number 2 becomes 3x minus 1 upon x minus 2 the whole square. A is 3 and B is 5. Now equation number 1. From 1, this will be the integration of 3 upon x minus 2 plus 5 upon x minus 2 the whole square. After this, I'm going to individually integrate this. Integration with 3 and 5 outside. Integration with 3 and 5 outside. Individual integration. Okay. Then this will be log mod x minus 2 upon dy dx of x minus 2. 5 integration of x minus 2 dx. Then you can solve these using x raised to n. Okay. Here down you can also write d by dx of x minus 2. And the second integral will be x raised to n. Okay. Solve it and simplify. So in this manner, the problem gets over. So guys, last category of partial fractions, PF type 4 linear and quadratic factors. Okay. So we'll be solving a problem based on this. Exercise 15b. Exercise 15b. Let's solve question number 12, sub question 2. Question number 12, sub question 2. Okay, that is integration of 2 upon 1 minus x 1 plus x square dx. Now look at the problem. The degree of the numerator is 0 because there is no x term. Okay, degree of the denominator is 3 because if you multiply these two brackets, you will get x cube somewhere. Degree is less. Degree of the numerator is less than degree of the denominator. So what we are going to do is we are going to apply PF type 4 because one factor is linear and the other factor is quadratic within the bracket. So it is linear and quadratic factors. Okay. So we'll write this as 1, equation number 1. So 2 upon 1 minus x 1 plus x square is equal to a upon linear factor plus bx plus c upon quadratic factor. So the quadratic factor is 1 plus x square. Okay, the quadratic factor is 1 upon 1 plus x square. So above the linear factor, we are supposed to place a. Above the quadratic factor, we are supposed to place bx plus c. And that's the format of partial fractions. Basically, that's the format of partial fractions. Equation number 2. Equation number 2. Okay. So 2 upon 1 minus x 1 plus x square is equal to, let's take LCM. It's 1 minus x into 1 plus x square. A into 1 plus x square plus bx plus c. Now put this bx plus c within the bracket. It's very important. If you don't put this bracket, calculation wise, many things will go wrong. Into 1 minus x. Okay. So cancel out the terms in the denominator. So this will be 3 over here. Equation number 3. Okay. Everybody has understood. Above the linear factor, we are supposed to place a. Above the quadratic factor, we are supposed to place bx plus c. Take LCM and then cancel out. Now look at the first factor. Look at the first factor, that is 1 minus x. Equate it to 0. The value of x will be 1. So put x equal to 1 in equation number 2. Put x equal to 1 in equation number 2. Okay. So 2 is equal to a into 1 plus x square. In equation number 3, sorry, not in 2. So 2 is equal to a into 1 plus 1 square, b into 1 plus c into 1 minus 1. So 2 is equal to a into 1 plus 1 square plus b into 1 plus c bracket 1 minus 1. Now the second entire term will be 0 because 1 minus 1 is 0. Right? So 2 is equal to a into 2. So a will be 1. A will be 1. We got the first value of x, first value of the uh, partial fraction method, okay, getting applied over here, and a is equal to 1. Now in this fourth category, whenever it is linear and quadratic, compulsorily by default second iteration you have to put x equal to 0. Compulsorily, you have to remember this. By default second time you have to put x equal to 0. Okay, so put x equal to 0 in equation number 2. Put x equal to 0 in equation number 2, in equation number 3. Okay, so 2 is equal to a 1 plus 0 square plus b into 0 plus c into 1 minus 0. Fine. So 2 into a. 1 plus 0 square is 1. 1 into a is a. Plus c. This is c into 1. So 2 is equal to, the value of a is 1. 1 plus c. So c is also equal to 1. C is also equal to 1. Now for the third time, you are supposed to take the value of x as anything apart from 1 and the 0 which has already been taken. Anything apart from 1 and 0. Okay. So let us put x is equal to 2. Take simple values in equation number 3. So 2 is equal to a into 1 plus 2 square, a into 1 plus 2 square, plus b into 2 plus c, b into 2 plus c. Let's put a bracket. I said this bracket is very important. Into 1 minus 2. Into 1 minus 2. Okay. So 2, the value of a is 1. 1 plus 4. Value of a I am taking from the previous step. 2b into 1. The value of c is also 1. I have taken from the previous step. And 1 minus 2 is minus 1. Okay. So 2 is equal to 5 plus. Let's multiply this minus 1 inside. So it will be 5 minus 2b. 5 minus 2b minus 1. So 2 is equal to 4 minus 2b. Okay. 2 is equal to 4 minus 2b. 2b is equal to 4 minus 2, which is 2. And b is 1. We got the value of b as 1. So in this particular problem, a, b and c all are equal to 1. Now put the values of a, b and c in equation number 2. Put the values of a, b and c in equation number 2. A, b, c as 1 in equation number 2. Okay. Put a, b, c values in 2. Right. So 2 upon 1 minus x into 1 plus x square. A is 1. 1 upon 1 minus x plus bx plus c upon 1 plus x square. Okay. So wherever there is a, b and c, I am putting 1 in equation number 2. Right. Now from 1, integration. Look at equation number 1. We have got the value of this. Okay. 1 upon 1 minus x plus x plus 1 upon 1 plus x square dx. Fine. Okay. Now here we have to substitute. We have to split. Sorry. X upon 1 plus x square plus 1 upon 1 plus x square. You have to split the integral into two parts. First integration will remain as it is. So this will be integration of 1 upon 1 minus x dx plus x upon 1 plus x square. X upon 1 plus x square dx plus 1 upon 1 plus x square dx. Okay. Now this is an easy thing to solve, not very difficult. First thing will be log mod 1 minus x, because this is 1 upon x formula. X is 1 minus x upon d by dx of 1 minus x plus I'll multiply and divide with 2. I'll multiply and divide with 2 plus tan inverse x. The last thing is the formula for tan inverse x. Okay. The reason why I'm multiplying and dividing with 2 is because the derivative of 1 plus x square is 2x. Okay, out of which x is already present. Okay, so now this becomes f dash x upon f of x, f dash x upon f of x. Okay, so now in the next step, 1 minus x derivative will be -1. Okay, and here I'm going to apply the property log mod f of x plus tan inverse x. So I'll write it down for you. Log modulus 1 minus x upon -1 plus half log mod f of x plus tan inverse x plus c. Okay, log mod 1 minus x upon -1 half log mod f of x. F of x is 1 plus x square. Okay, plus tan inverse x plus c. So this was the complete solution for linear and quadratic. Okay. Okay, so let us go to question number 22 of exercise 15b. Integration dx upon x plus x square plus x cube. X plus x square plus x cube. Okay. So I'll write this as 1 upon, take x common, 1 plus x square dx. This is equation number 1. X is linear. 1 plus x square is quadratic. The degree of the numerator is 0, degree of the denominator is 3. We can apply partial fractions. But then in this case, I am going to apply partial fractions type 4, that is linear and quadratic. You can copy along with this. Okay. One upon x, 1 plus x square is equal to a upon x. Linear factor will have a above it. Quadratic factor will have bx plus c. 1 plus x square. This is equation number 2. Take LCM. Bx plus c, always within the bracket. Always within the bracket. Compulsorily bx plus c should be within the bracket. X into 1 plus x square. X into 1 plus x square. So cancel this out. We will be getting equation number 3. Equation number 3. Fine. So 1 is equal to a. Sorry. Let us go to the equation number 2. Let us equate this x to 0. So the value of x is naturally 0. So put x is equal to 0 in equation number 3. Put x equal to 0 in equation number 3. Okay, so 1 is equal to a 1 plus 0 square plus b into 0 plus c into x. X is 0. Okay, so this entire term became 0. So 1 is equal to a into 1. That implies a is equal to 1. That implies a is equal to 1. Okay. Now where to put this a equal to 1? Maybe later we have to substitute this a is equal to 1 in the second iteration. Let's go to equation number 2. See, now when we are putting x equal to 0 for the first iteration, second time compulsorily we had to put x equal to 0, right? If you remember the previous problem. But then x equal to 0 we have already substituted. So in the next iteration we'll take value of x as something else apart from 0. So put x equal to 1. Put x equal to 1 in equation number 3. 1 is equal to a into 1 plus 1 plus 1 square bx plus c. So b into 1 plus c into 1. B into 1 plus c, the entire thing into 1. And the value of a is 1, which we have already got. So a into 3 plus b plus c. So this will give me b plus c is equal to minus 2. We'll get one equation over here. Equation number 4. Okay. In the next iteration, put x as 2. Put x as 2. Because see, 0 we have already tried. And x is equal to 0 is a compulsory thing in linear and quadratic. So we have already done that. In the second iteration, we have taken x as 1. Now take some other value of x apart from 0 and 1. Let's take x is equal to 2. Let's put x is equal to 2 in equation number 3. Okay. So 1 is equal to 1 plus 2 square a into 1 plus 2 plus 2 square b into 2 plus c into 2. So wherever there is equation number 3, put the value of x as 2. Okay. And also in the next step, replace the value of a as 1. A is 1 and this thing is 4 plus 2 6 plus 1 7 plus 2b plus c
B
into
and C
2.
are minus 1.
Okay. So 1 minus 7 is equal to twice 2b plus c. Minus 6 is equal to twice 2b plus c. So 2b plus c is equal to minus 3. Let this be equation number 5. Now if you solve equation number 4 and 5 simultaneously, if you solve equation number 4 and 5 simultaneously, you will get the value of b and c. So let's solve equation number 4 and 5 simultaneously. B plus c equal to minus 2. 2b plus c is equal to minus 3. Subtract both the equations. Okay, so c will get cancelled. B minus 2b is minus b and minus 2 plus 3 is 1. So b is equal to minus 1. B is equal to minus 1. So put b is equal to minus 1 in equation number 4. B plus c is equal to minus 2. So minus 1 plus c is equal to minus 2. C is equal to 1 minus 2. C is equal to minus 1. So I got the value of b and c as minus 1 and minus 1 respectively. Now put the value of A, B, C in equation number 3. Put A, B, C in equation number 3. So in equation number 2, sorry, not in 3. If you take a look at equation number 2, okay, I'll just put the value of A, B, and C. So 1 upon x, 1 plus x square, the value of A is 1, the value of B is -1, and the value of C is -1. So from 1, integration 1 upon x, okay. Let's take this minus sign common, okay, and write minus over here. So this will be x plus 1 upon x square plus x plus 1. Okay, this minus sign common I've taken and I'm putting it over here, right? Okay. So next step, I is equal to integration of 1 upon x is log mod x. I is equal to log modulus x minus I1. I'm taking this as I1. Okay. And I will solve it separately. I1 is equal to x square plus x plus 1. Now we cannot factorize the denominator. Okay. The derivative of x square plus x plus 1 is 2x plus 1. So we will have to make this as 2x plus 1. Okay. So multiply and divide with 2. First step is multiply and divide with 2. Second step is to add 1 and subtract 1. Add 1 and subtract 1.
So can you go on the previous slide once?
Yes.
So I1 is x plus 1. Now you've written only x.
Oh, yes. Sorry. X plus
And
1.
minus outside, but
Oh, minus I'm not taking into consideration for I1. This minus will remain as it is over here. Okay. So let me just correct this. First I have written the derivative of x square plus x plus 1 is 2x plus 1. So first I will make this as 2x, okay, by multiplying and dividing with x. So this will be 2x plus 2 upon x square plus x plus 1 dx. Okay. Now we are supposed to make this as 2x plus 1. So the 2, which is a constant, will be split as 1 plus 1. So in the next step, I'm going to write this as half 2x plus 1 up plus 1 upon x square plus x plus 1. Now I'm going to split this into two parts. 2x plus 1 integration of 2x plus 1 upon x square plus x plus 1. And remember, this is I1, okay? Plus 1 upon x square plus x plus 1 dx. Okay. The first part will be f dash x upon f of x. And second part will be half into coefficient of x the whole square. That is how we have to solve I1. Once you get the value of I1, put back in I. You can put this value in I. Now what is I? I is this. You can put the value of I1 in I. Okay, once you solve this. So this is I1. Fine. So this will be a bit lengthy procedure, but then you have to keep yourself on track. I'll be giving hints for couple of problems. You can solve it for your practice at home. But then the hints are as follows. Question number 21. Integration of 2x upon x cube minus 1 dx. So this is 2x upon x minus 1 x square plus x plus 1. So what I've done is x cube minus 1 cube, a cube minus b cube. So a minus b, a square plus ab plus b square, a square plus ab plus b square, right? Fine. So the first thing is linear and the second thing is quadratic over here. Fine. First thing is linear, second thing is quadratic. So you can solve this using linear and quadratic category. One last problem of which I'll just share the hint. Okay, question number 19. Integration of 1 upon 1 plus x square plus x cube. Okay, so down from the first two terms take x1 common, and from the next two terms take x square common. Take x square common. Okay, so this will be 1 upon 1 plus x into 1 plus x square dx. The first thing is linear, second thing is quadratic. So you can solve this using the fourth category, that is linear and quadratic. That's it. All four categories of partial fractions is over.